Okay, so let's try question 4, which was roughly based on the few responses we got from Saturday's paper, was the next highly rated one that you guys want to have a look at. Okay, so a book club, 6 paperbacks and 2 hardback books. Okay, she's choosing 4 of them to take away with her on holiday, and we're looking at how many of the how many of the books end up being paperback books, right? So let's just draw for ourselves. We've got 6 paperback and we've got 2 hardback. I know, I always like to draw stuff out even if you don't need to. Somehow it makes me feel like I've started to solve the problem, do you know? Even though, of course, there's a little bit more to do. So I'm going to show that the probability that she chooses exactly 2 paperback books is 3/14. There's 2 ways that you can do this. One way is to use combinations, and one way is to use a tree without replacement. So a tree without replacement would involve you doing 4 stages of your tree and then looking at paperback versus hardback for each one. So, for example, it would look like this. So the first book she could choose could be paperback or hardback, and it would be 6/8 for a paperback and it would be 2/8 for a hardback, right? So the next sort of book that she chooses, if she chose a paper book, there'd be 1 less paperback, available, so there'd be 5 left, and there would be 1 less book, so there'd be 5/7 would be the chance. The second one's a paperback as opposed to 2/7 for the hard back, and so forth. And you can see that you could do that. You could keep doing that, and that would be fine. Of course, it could end up being quite messy. The good thing about this, I suppose, is that because there's only 2 paperback books on your tree, you're going to sort of come to an end point at some stage, because suddenly you can't have any more options. So, for example, here, if you chose a hardback on the first one, and then you choose a hardback on the next one, there's no more hardbacks left to choose. So therefore your next one would have to be a paperback, and so forth. So your next 2 would have to be paperbacks. And here, of course, we could still have 5/7 chance of a paperback. Would still have here 2/8 chance of a hardback, and so forth. Okay, so you could draw out your whole tree and then use that to multiply across. But I suppose when you've got 4 books you're choosing, that could be quite a lot of options to consider, and then you still have to go back through and multiply across the tree to find out what you want. So actually in this case, the easiest way to do it is actually to use combinations, because you're choosing books out of a certain number of books. In this case here, you want exactly 2 paperback books. So what you can say is that you want to choose from the 6 paperback, you want 2 to be paperback, which means that you want the other 2 to be hardback. And of course, there's only 2 that are left to choose, so it's 2C2. And then to turn that into a probability, what you've got to do is divide that through by all the possible ways that you could choose 4 books out of these 8 in total. So it'd be 8C4. And because you don't, because for the denominator it's got to be all the different ways you can choose the books, don't need to worry about which weighting it is, so you can just do 8C4. Cool. And so if you work that out, you will get an answer of 3/14. Okay, so then part 2 just wants you to consider the probability distribution table, and you guys need to be prepared for that, to set up one yourself. And that just involves going through and thinking X, up here they've told us X is the number of paperback books she chooses. And what's really important when you set probability distribution tables is that you remember to put in 0 as an option. Okay, so we're looking at how many paperback books she wants. We'll call that X, and then we're looking at the probability that she does select that many. So it could be 0, it could be 1, it could be 2, it could be 3, and it could be 4. Okay, now you've already worked out the probability of 2, which was 3/14. And we're leaving it as a fraction because at the end, it's easier to deal with this with fractions, plus you're not going to round it too early and introduce error into your answer as well. Now, in this case here, I've drawn that up like that for you to see, but I just want you to remember not to forget 0 as 1. In this case here, though, because there's only 2 hardback books, and that means she will have to take at least 2 paperback to get 4 in total. So in this case here, we actually don't have to have 0 and 1. You could have 0 and 1 on there, by the way. You could. The thing is, you just have 0 as the probability and 0 as the probability. So it's not wrong. It's just that, obviously, the outcomes for that. The probabilities that match those outcomes are 0. So we might as well just leave them off for now. Right. So then we just need to work out 2 other probabilities. In fact, actually, we only need to work out 1 more probability, because then what we can do is just subtract the probabilities from 1 to get what's left over. So if we go for selecting 3 paperbacks, so she wants 3 paperbacks, which means she wants 1 hardback. So that's going to be 6C3 for the paperbacks times 2C1 for the hardback, all over 8C4. Okay, and so if you work that out on your calculator, you end up with 4/7. And I'm going to turn that back into 14ths just so that it's in the same denominator as my other fraction there. So if that's 8. If that's 8/14ths there, get rid of that one there. So it's 8/14ths. So that means I've got 11/14ths across outcomes 2 and 3, which means this last one here has to also be 3/14ths. Okay, and that's my whole probability distribution table. And for part 3, they want you to work out the variance, and they tell you that the expected value is 3. Well, you can see that anyway from the table, because you can see that there's 3 outcomes. You can see this is symmetric, so 8/14ths is the highest probability out of those 3 outcomes. So therefore, yeah, the mean is 3. But anyway, so they're giving us the mean is 3, so all we have to do is work out the variance. I was trying to move the other way, but I can't seem to, so I'll just make it a little bit smaller. Up there. Okay, so what we know is that the variance of any random variable, if this is a discrete random variable, is going to be the e of x squared minus the e of x all squared. Okay, and we know what the e of x is. It's 3, so that's going to be minus 9 once we've squared it. We need this part here, the e of x squared, which we get from squaring the outcome. So 2 squared, and then timesing it by the probability. So by 3/4. Same thing here, 3 squared times by 8/14ths, plus 4 squared times 3/14ths. Okay, so that part there gives us 66/7, and I would be entering that onto my calculator as fractions throughout. So 2 squared times 3, ABC 14, and so forth all the way along. Okay, so then if we just finish this off as our calculation up there, then the variance of x equals 66/7, which is e of x squared, minus 9. Okay, and that gives us 3/7.